So welcome to lecture 2. So in this lecture we'll talk about composition of functions. So in this section, once you complete this, you should be able to combine functions using algebraic operations. You should be able to create a new function by composition of functions. You should be able to evaluate composition functions, and you should also be able to find the domain of a composition function, and finally decompose a composition function into its component functions. So let's start with combining functions. So when you have two functions, you can also do all algebraic operations on that function. You can add, you can subtract, you can multiply, and you can divide. So what happens here, if you have f plus g of x, can be written as f of x plus g of x. F minus g of x becomes f of x minus g of x. Fg of x can be written as f of x times g of x, and f by g of x becomes f of x by g of x. So this is only under the condition that g of x is to not be equal to 0. So with this in condition, let's try a simple problem. So they have given us two functions, x square plus 2x and 6 minus x square. So let's try and calculate the first one, which is g plus f of x. So which becomes g of x plus f of x. Write down the function as it is. So g of x is 6 minus x square plus f of x here is x square plus 2x. So that becomes minus x square plus x is gone. You have 2x plus 6. So this is the function g plus f of x equals 2x plus 6. Next you have g minus f of x. So that becomes g of x minus f of x. So remember that always use the order in correct order. So you have 6 minus x square minus of x square plus 2x. You have 6 minus x square minus 2x. So it becomes minus 2x square minus 2x plus 6. So this is the value for g minus f of x. Next we want to find gf of x. So fg of x becomes f of x times g of x. F of x is x square plus 2x times 6 minus x square. So when you multiply, you should get 6x square. Remember the FOIL method. So first terms, next outer terms minus x power 4. Next, so inner terms are 2x and 6 plus 12x. Next outer terms minus 2x cube. So when you simplify, you should get minus x power 4 minus 2x cube plus 6x square plus 12x. So this is the value for fg of x. Next, the last one we want to do here is f by g of x, which can also be written as f of x by g of x. So f of x here is x square plus 2x by, so x square plus 2x by 6 minus x square. If you can simplify, you can simplify. For example, x square plus 2x can be written as x times x plus 2. However, 6 minus x square can be written as x minus root 6 times x plus root 6. If you don't want to, you can just write it as 6 minus x square and leave it that way. So this is your answer for the last problem. So this is how we can solve algebraic operations on functions. Next, let's talk about composition of functions. So what we call a composite function. So we define composite function as f circle g of x. What does this f circle represent is that basically f is going to engulf itself into g of x. So this is written as f of g of x. So what basically means that we are taking x in the function of f and replacing it with entirety of g of x. Remember that f of x times g of x is not equal to f of g of x. This is a major comparison that you have to remember, because this is generally not equal to the case. So let's try this example here. For the first one, let's find f of g of x. So first, write down what we do know f of x. F of x is x square plus 9 and g of x is under root x plus 5. So just write down f of x but without writing x first. So x square plus 9, but in place of g of x we have to replace it with the value. So f of root x plus 5 equals, so you will get root x plus 5 square plus 9. So square and root get cancelled, so you get x plus 5 plus 9, so which becomes equal to x plus 14. So this is the value for f of g of x is gonna be x plus 14. Now it's not always the same that f of g of x should be equal to g of f of x. So in this problem, let's try and find g of f of x. So you have g of f of x can be written as, you have f of x is x square plus 9, so let me write it down here, and g of x is under root x plus 5. So g of f of x, so in place of g f of x, write down the f of x function itself, x square plus 9. So that equals, now what is this function? How would you write this? Just replace x with this value. So the function originally is under root x plus 5. So in place of x, write down x square plus 9. So remember that we are just replacing the value with the function. So that's what we do here. So it becomes x square plus 9 plus 5 becomes 14. So g of f of x is under root x square plus 14. F of g of x is x plus 14. So it's not always true that both should be equal. So when you do one, the other might not be the same. So f of x, so f of g of x is not equal to g of f of x, but it's only equal under special conditions. It can be equal. So under special conditions, it can become equal. Now let's try this. Try this problem here. So you have f of x and g of x. They are asking us to find f circle g. So this 0 here is represented as a circle, right? So we write it, we say it as a circle. So f circle g of x can be written as f of g of x. So the one that is later will be engulfed by the first function. So f of g of x here is 2x power 4. So what we are doing here, in place of x, write 2x power 4 in the function f of x. So that becomes 1 by, in place of x, we have to write 2x power 4 whole square plus 1. So that becomes 1 by 4x power 8 plus 1. So this is the value for f circle g of x. So this is the value for f circle g of x. So use the same principle now. So they are asking you for g circle f of x. Remember the formula. The one that is after the circle gets engulfed by the first function. So it becomes g of f of x. So pause the video right here and try to solve this problem. So next, let's try and find using the values in a table. How would you use a table to find out these values? So we need to find f of g of 1. So the first thing that we do here is to find the inner part. So g of 1. G of 1 is g of x where x equal to 1. That value here is 3. So we know that g of 1 becomes equal to 3. So f of 3. Now in place of x, look for 3 here. So for 3, the f of x value is 3. So this is the answer for f of g of 1. In the same way, next let's find for g of f of 4. So first we have to find f of 4. So in place of f of x should be 4, that value is 1. So g of 1, that becomes equal to, so g of 1 is again 3. So notice that this is a special case, and you notice that both functions are equal. So this is how we can find using a table. Next one is to find using a graph. So how would you evaluate from the graph this value g of f of 2 First we find f of 2. In the function f of x, for x equal to 2, calculate the value for y. So f of x, that value becomes 5. So g of 5. Now what do we do here? G of x on x-axis, wherever the value is 5, check for where it intersects with the axis, that value is 3. So we found that f of 2 is 5 and g of 5 is 3. So this is how we evaluate from the graph. Now, so use the same principle here and try to find out these problems here. So pause the video right here and try to solve these problems. Next, how do you find the domain of a composite function? So the domain of a composite function is basically the set of x values of g for which g of x is the domain of f. So how do you understand this? First, we find the domain of g. Second, we'll find the domain of f. And we'll find those inputs x in the domain of g for which g of x is the domain of f. So let's take an example so that we can understand it pretty better. So for this problem, we have f circle g of x. So we have to find it here. So first thing is that we have f of x equals 1 over x minus 2 and g of x, which is under root x plus 4. First find domain for both f of x and g of x. So when you want to find domain for f of x, x minus 2 should not be equal to 0. And in the second one, x plus 4 should be greater than or equal to 0. So x should not be equal to 2 and x should be greater than or equal to negative 4. So if you don't want to write this way, remember that we write minus 4 on both sides. So 4 and 4 get cancelled, so x greater than or equal to negative 4. Now we have two different functions that we have to find the domain for, and we have to find it for its composite value. How would you find this? So from this, how do you solve this problem here? Is that, remember, f circle g of x is f of g of x. So which means that first g of x here should never become infinity. For that to never become infinity, x value should always be greater than or equal to negative 4. Now for the whole function to be stable, g of x should never be equal to 2. Right? So now use the function g of x not equal to 2, because remember that if it is equal to 2, then you will get infinity for f of x. So we don't want that to happen. So when g of x is not equal to 2, so we have x root x plus 4 not equal to 2. So x plus 4 not equal to 4. So when you square on both sides, x not equal to 0. So this is the two conditions that we have to remember. This is 1 and this is 1. Never take the condition for f of x only use it as a substitute for the other function. Now we have two conditions, x should not be equal to 0 and x is greater than or equal to negative 4. So when you write it on a number line, we have 0, we have negative 4 here. So when you write it from x greater than or equal to negative 4, it starts here and it goes towards infinity. So you don't want all the values. So what you want is, you want to cut this value exactly at 0. So write it until here, and from here write it continuously again. So how would you write it as a domain here? So how will you write this as a domain here? That value becomes, you are writing from negative 4 to 0 without 0. So which means that we are excluding 0 and including negative 4 union, and we are excluding 0 again until infinity. So this here is the domain for the composite function here. So let me do another problem so that it becomes easier. So let's say we have So let's try to solve this one here now. Again, first find the domain of x, so that becomes x not equal to 1, and in the second one x not equal to 2 by 3. So I'm not solving it fully, but you already know the values. Now we have to find for f circle g of x. So f circle g of x is f of g of x. Here g of x should not become equal to, remember that in f of x, which is not valid, x is not equal to 1. So which means that g of x here should not be equal to 1. So g of x should not be equal to 1. So write it down here. So you get 4 by 3x minus 2 not equal to 1. So 4 not equal to 3x minus 2. 4 not equal to 3x. Sorry. 4 plus 2 not equal to 3x. So 3x not equal to 6, x not equal to 6 by 3, so that becomes 2. So these are the two functions for the total function. Remember that the one that is inside is the one that we are looking for. We are not looking for anything else. So we are only looking for the conditions based on the inside part. Now we have two conditions, x not equal to 2 and x not equal to 2 by 3. So how would you write the domain here? So if this is the function here, this is the value of 2 and this is somewhere is 2 by 3 and this somewhere is 0. So we want to include everything except for 2 by 3 and 2. So what do we do here? First we will write from negative infinity until 2 by 3 and again between 2 by 3 and 2 but excluding both the two values, and then from again 2 to infinity. Now how would you write this as a function? So open interval negative infinity comma 2 by 3 closed interval open interval union open interval 2 by 3 comma 2 open interval union open interval 2 comma infinity. So this is the function that we can write for this particular domain. So this is the domain for this particular composite function. So remember again, I'm going to repeat it again. Remember that g of x, because f of x, f of g of x, and this g of x should not be equal to 1, because if it is equal to 1, then this function becomes infinity. So we don't want that to happen. So we are writing it as g of x should not be equal to 1. So we are basically replacing the domain from f of x that we found with g of x, and we are writing it down as a function. So using this principle, we finally found our domain. So this is how we can find the domain of a composite function. So pause the video here and try to find the domain of this function here. So with this, we end the lecture on composition of functions.